Pre-Calc 11, Chapter 5.1. We're going to be looking at solving quadratic inequalities in one variable. And the more you understand about the characteristics of quadratics, the easier this section becomes. Now, we have two types of inequalities. We have strict. This means it's less than a number or greater than a number. And we have not strict. So this means we have less than or equal. And we have greater than or equal. And again, we have the condition a does not equal 0, since if it was 0, it would become a line. Now, we can replace y is equal to ax squared plus bx plus c, and think of this as y being less than 0, y being less than or equal to 0, y being greater than 0, or y is greater than equal to 0. So the key here is we are always comparing y with 0, not x. And we want to find out the domain that fits this condition. So here's an example. Find the domain of minus 3x minus 4 is greater than negative x squared. And we're going to do stuff that you've already seen before. X squared minus 3x minus 4 is greater than 0. We're moving the x squared over to the other side. We factor. And we solve. X is equal to negative 1 or x is equal to 4. So we solve for the roots. Now, what you want to think of is when do we get a positive y? So we have x plus 1 is greater than 0, and x minus 4 is greater than 0. And this time it is an and. We take the most restrictive one, so x is greater than 4. And this is true because if we have a positive times a positive, we get a positive. Now we need to check the negative times the negative. So we need to have x plus 1 is less than 0, and x minus 4 is less than 0. Is the more restrictive condition. Most restrictive. And what we're doing here is called sign analysis. We're checking the sign. And the other way to write this is just x is greater than negative 1 and x is greater than 4. And we have the same condition. So x is greater than 4. And we also have x is less than negative 1 and x is less than 4. So if we had x is equal to 3, 3 is greater than negative 1, but 3 isn't greater than 4. So this condition is not true. That's why x must be greater than 4. Again, if we check down here, say x is 3, 3 is not less than negative 1, 3 is less than 4, but both conditions need to apply. So we have x is less than negative 1. And another way to think about it, if you aren't required to show the algebra, we look at this case. Concave up. This function is concave up. The only possible places for y to be positive is on the outer interval. Okay, if we look at concave down, this is not our function, but if we looked at concave down, the only place that can be positive is the inner interval. And here we have the outer. Only inner interval. So again, this is thinking about the characteristics of a quadratic function. So the warning here is if you start with strict inequality, your answer must be a strict inequality. And if it starts off as not strict, it must end off not strict. You can't change the type of inequality in a question. Okay, we need a definition, critical points. Are the zeros of the quadratics. And we can use test points around the critical points to determine the domain or the intervals. Okay, so we're looking at the same example. Our critical points are -1 and 4. So we try -2. This is called the test point. We plug in -2 here. -2 plus 1 is -1. And we have -2 minus 4, that's -6. And we don't really care about the answer, but this one's easy to compute, so we'll just say 6. What we care about is the sign. So in the interval from -infinity to -1, it's true. So x is less than -1. Let's try the test point 0. Here we have 0 plus 1, so that's 1. And 0 minus 4, that's -4. It's negative. This is the y value. This means the interval between -1 and 4 is negative, and it's not part of our solution. Now, x equals 5 is another test point. 5 plus 1 is 6. And 5 minus 4 is 1. So this is 6. So the interval from 4 to infinity must be part of our solution. So x is greater than 4. And again, notice or in the answer. It's not both at once. It's one at a time. So regardless of which method, we must always find the zeros or roots. So this is your first task when solving for inequalities. And you need to learn all the methods because a test may ask you to use a specific one for an answer. Let's look at special cases. Minus x squared is greater than or equal to 6x plus 9. Let's move everything over to the left-hand side. Minus x squared minus 6x minus 9 is greater than or equal to 0. Divide everything by -1. So it becomes positive. We flip the inequality. When multiplying or dividing by a negative. And now we factor. So our answer is x equals -3, since x squared is not less than 0. Okay, graphically it looks like this. So x plus 3 times x plus 3 can equal 0, but it can't be less than 0. And it's 0 when x equals negative 3. It's the only y that is less than or equal to 0. Okay, let's look at another special case. Let's divide everything by negative 1. So we flip the sign of everything, and we flip the inequality. Now we need to complete the square. And we just add 1. And we have x minus 1 squared. Move the 3 over to the other side. It becomes negative 3. Since this will always be greater than or equal 0, we can say 0 is greater than negative 3, and this is always true. So, x is all reals. And if we look at the graph, all the y values are greater than 0. So this is a graphical reason why our solution is all reals. And just a reminder, we're always checking the y values to see if they're greater than or less than 0. And what we're doing is finding the domain where that happens. And that completes this lesson.